Hey everyone, how's it going? Quick question for you. Do you want your filament to dry evenly every time? What if your filament could automatically rotate like so as it's drying? Well, now it can. I built a modification for the Sunlu S4 filament dryer that does exactly just that. In this video, I'm going to show you what it does, how it works, and where you can find it and make one on your own. Let's get started. So here's the deal. Filament dryers like the one that I have, the Sunlu S4, have PTC heaters in the chamber somewhere. With the fans pushing the heat around, make a virtual cocoon in itself that tries to evenly distribute the heat all around. Pretty standard, almost every filament dryer have that. The thing is, when the spool is static and it's not moving and it's just sitting there, the fans push the air all around. And when the top is here, it pushes it, bounces around, comes in, tries to dry here, here, and here. It does a pretty good job. What you still end up with hot spots and cooler spots. It doesn't mean it's not working, but it's just kind of uneven. I believe that has been proven with many other videos online. And it's not, like I said, just the Sunlu that does this. In general, this is how it works. I just happen to have the S4, so I made the upgrades for the S4. That's where it comes in. This upgrade comes in. You do the upgrade, you print it, you modify your unit. When you put it on, there's a switch in the front. You click it, and the spool just starts spinning all on its own until you turn it off. So yeah, in theory, if I'm not wrong, the time that it takes to dry should, I don't want to say be cut in half, but instead of drying for 5 hours, maybe you can do for 4 hours or 3.5 hours, because now the spool is actually spinning around and getting every single part evenly throughout the whole drying process. So now let's jump into CAD. I will show you my design process, where I started from, where I ended up, what parts I made, and then we will show you how it all gets put together. Right, let's jump in. Here in CAD, this was my design option or revision number 1. What this did was I built everything in a box. This is the motor that I was using, or I'm actually using in this project. We got a little notch here, got the axles coming out of it. What I did was this is the back. So if you're standing right on top of it, this is what you're going to see. So the motor was going to go right here, and that notch right here on top is this right here. So it was going to be a stabilizer so it doesn't move around. And then the axles come out from here, this goes out from here, and then we would have had the gears here and gears here. This was working. Well, in theory, in my head, it was working until I started to play with this, print out a sample. Then I said, it's going to be really tall. With this height, I'm going to have a few problems where if the first axle decides to come out from here and the spool is down here, we were going to have to make a lot more axles to do a step down and to have an opening down here to pass it through. It was going to be a lot of work. It would work, but it was going to be a lot of work. So I kind of scratched that idea. Then I came up with this idea. Almost the same concept, minus it is not a huge box. This is now the motor is sitting vertical. So the motor is sitting here. We have a little support here so it doesn't topple over. and we have the, oh wait, no, there's the hitch, or the notch, I should say, sits right there. So you know what orientation it goes in, and so it doesn't move over. Then we have the axles that were going to come from here and here. This in theory would have worked, but then I started building idea in my head, and I said the gears, the spur gears, if I was to create them, would be this big. If you can see, that's huge compared to what I have now. Let's get another color. So what I have now versus what I have. That was a difference. I would have needed to make a bigger hole in the Sunlu to pass these through. I did not want to do that. And this one was also not fully finished, as I needed to make another extension onto here so I can pass the other gear over it. So again, good idea, but I passed over it. Then the final design of this process was this guy here. I laid the motor down and everything kind of clicked in place. It was as if this gearbox was made for this unit here. I structured this, I built legs. So you'll see in a minute what I'm talking about. I built the legs so it sits flush at the bottom. It doesn't topple over. And then we have these supports here where the motor goes into. So the motor goes into this guy here like this, and we have the notch on top that sits in place where now it's firmly in place and it doesn't move. And we have these supports on the sides here where they're keeping it from moving around. I also have a little wire channel that it will exit from, like so. And then we have where the gears are gonna go, and then the axles that will go from right there to right there, not drawn to scale. Please don't judge me on that. But yeah, so the overall design is this, and the printing is done just like this here. This is how we print it. We have supports for this guy, this guy, this guy, and then we have another big one that goes from the ground all the way to the top from here to here. I've printed this in ASA and I've had no problems with the supports coming off, so I don't think you will have any problems. Then what we have here is the left and right roller rods or axles, however you want to call them. They go into these output shafts for the motor. They go in with these little notches in here, and they're pretty firm. And I built this these notches in the rods, so when your gear goes into the rod, it doesn't have an angular play to it. It's very firm. This one here, when I printed it originally, it kept playing, and also it was very tight to put the gear in. And after a while, when this was spinning, sometimes this would get caught. The plastic would mesh and it would get bigger and bigger, and then you would get these plays in there. So I put this in here notch so it goes in one way and it doesn't spin. So if you don't want to put the screw in here to hold it in place, you don't have to. And then I built this after testing this exact scenario out here. I then noticed that there was a problem with this portion here. When the gear was touching the other one, it would every now and then lift up, just lift a little bit, go up and come back down. So I created this bridge like so, that will, once you close the bottom base, it's closed shut, it puts a bit of a force down here and keeps these wings flush and down, so it doesn't move. And it also prevents it from, when you flip it over, prevents everything from falling down to the ground. So that's that. And then we have the gears, regular mesh gears, or spur gears I should say. This works perfectly fine. They rotate just normal. There's no grinding. The only thing I did to this particular one here is I cut the inner circles to the sizes that I needed them to be, and then this is exported by separately, because then what I did was, for the larger gear, I made these little indents in here so it goes into the rod, and I left one side out for the screws. So the screw is an M2, if I'm not wrong, M2 screw that goes in here, that pushes against the rod if you choose to use. That will secure the gear in place so it doesn't move around. This is for converting the 12 volts down to a 3, 2, however you like. If you want it faster, you can give it more juice. If you want it slower, turn it down counterclockwise and you'll get less. Yeah, so this is where everything goes inside here. This goes on the side, in the back of the unit. Built these notches right here so it slides into place. You'll see in a minute here. It slides into place and it doesn't move. So everything's nice and secure. So that is all the files. Now I will print them out and I'll show you guys how each part gets assembled and what modifications you have to make on to the unit. There's a switch involved, there's soldering. So yeah, let's get started. This is the final print. This is what it looks like. This is, like I said, printed in ASA. For the most part, it came out great. The lines are straight. That's the support bridge. And here are the gears. But this is the gear, how it comes. It's very easy to put together. Take the gear, you put it in here like so, and then once you do that, you got to lift the top bridges or top support just a smidge. If you notice, it's going up, and now boom, that's it. And if you pull on it, it's pretty hard. And then the wires, you can take the wires, put them in this channel like so. Bring the gear all the way up to where it goes in here, and then slide it into the outside first, like so. And then put it into, you don't have to put it inside the motor yet. We'll do the next side. This one actually goes in a little bit easy. Then you can push in hold the motor from this side, push it in goes in nice and snug. And then same thing with this side. Push in on both sides firmly. There you go. Now it's not moving anywhere. The gears go back and forth, and the rod or axle is not coming out of place. At this point, I would say hold off on tightening down the screws because you're going to need to adjust them on the axle side or the roller side inside the Sunlu. The rollers inside the Sunlu, they look like this, minus this gear. They just pop out and only one side comes off, the bearing. Just try to see which one comes off. Just pull it, boom, it'll come off and it'll look like that. Then when you print these gears out, they look like this. You carefully put them on. At first they'll go on easily. Then as soon as you put them in, don't push them in, roll them in. So do this and keep rolling them in. Right as it gets to the edge, it'll get harder and harder. That's where you want to stop for now, because you need to adjust them. Then once that is adjusted, you can put it back. Then let me show you what necessary cuts you have to make inside. So here's what the inside looks like. This is the bottom, and when you take the top cover off, here's what it looks like. Yours will probably look like this, nice and clean. Mine looks like this because I've already made the cuts. So what you're gonna do is take the printed out base plate, like so. These, before putting the gears on, these cuts are already pretty much your template. You'll just take a Sharpie and you would trace around it on both sides. Then you want to lift it off, and then you just want to cut down as straight as you can, go up, around, make a nice long rectangle. Your final cut will look more like this than this. This was my original cut that I was working with. So it will look like that. Once the gear is inside, it will look exactly like so. Then when you're done, you put that back in place, gears, and then you can test them out by just rolling your finger over it like this. And if you notice it spinning, then you've done it right. All right, what we're gonna do next is put the switch into the body. And I got one of these switches. This switch here has a light right in the center. So there's two ways you can do this. The light can always be on, no matter if you turn it on and off, light's on. The other way is when you hit the switch, light will turn on. What we're gonna do now is where I decided to place this switch, I didn't want to do it in the back here, so I decided to do it here. I didn't want to do it in the front because I didn't want to drill through the clear plexi just in case it was to crack. It's nice, I just want to keep this all clean. So I'm going to do it right here. I've already put a pilot hole, and this lines up right in here, right there in the center. I just decided to do it here. This is where the bottom base will go, like so. And when you flip it over, the switch will be right there. Ah, look at that. It looks beautiful. Have a look. Hole. And no hole. The ring goes in the back and it's tight. It looks like it came with the unit. So one motor will spin both, and then this will turn on just this side, and then put another one here that will turn on just this side. You can choose to do only one if you like, or you can do both at the same time. If you have 4 spools in here to go, you can do that. But for the time being. I think one should be sufficient enough. This is what the buck converters look like. There is an input side and then there's the output side, or just input and output. What it does is it'll take the voltage from the input and convert it to whatever you desire by using this potentiometer. So what I did was, this comes as a standalone unit. These wires do not come with it. I soldered these on here. So this is the buck box, or the buck converter in here, and this is the box I printed. It's this little guy you see from, so this is the converter box that I printed. So it sits inside the power supply housing. The converter will go right in here, these notches, so it doesn't move around. It's very snug in there, so it's not gonna come out. I put a notch in here for the wire, another notch here for these two wires, notch here for this, so everything is coming out where they need to be. And then what I did was I took the 12 volt, which is this guy right here. This is the 12 volt unit from the system. I used these soldering heat shrinks. They're pretty cool. They look like this. You put the wire in from both sides, and when you apply heat right into the middle, then as you see right here, the solder pretty much just melts away and solders the joints while heat shrinking the sides. I took the 12 volt from here, I cut it, I joined it together here, I went to the input in here, so now this unit has 12 volts. Then I took the output, I went inside here, which comes out. So the wires come out from here. So you take the positive that comes out from the converter, which right here. So the positive that comes out from the converter is this guy right here. You go into the switch. I will put the diagram on the screen for you guys to see. It goes into the switch to provide the positive to the switch. Then you take the negative, do the same thing with the negative wire, which is the black one. Then you take the two wires of the switch, join them together, put them into one. You take the plus or the positive of the switch into this guy here. Then you take the negative and put it in the negative one, and you call it a day. Okay. With this unit here, what you want to do is, you can see the little adjuster right here. You want to take a really small, thin flathead, and as of right now, where my voltage is at, when I turn it on, as you can see, I was talking about that blue light. It's on, off, on. So right now, it's at 3. So if I was to, let's see, decrease counterclockwise, look at this dropping. And if I go clockwise, and it gets faster and faster. So the control is literally in your hands. However fast you want the spool to spin, that's all up to you. So yeah, again, you're playing with high voltage here, not in here per se, but in this direction and in here. Be super, super careful. There is plenty of channels in here. Once you open it up, you'll be able to see there's one channel here, there's another channel here. All these channels, they come from factory and they're meant for wires to go through. So this solid state relay switch can sit flush against this plastic right here. You don't want to be squishing any wires to cause a short. So the back is metal. So make sure all of these wires are tucked into these channels or they're going from the outside in. Once you screw it in, it should be completely flush and it should not wiggle around. Okay, this is what it should feel like and look like once you have this installed. I didn't fully screw it in yet, but if you notice, it's all the way down. And if I push here and here, it's just riding on its black, the silver plate that was underneath. There's no wires interrupting it. Okay, to finalize this bracket, to put it back in to its place, it's actually very easy. You want to take the wires and tuck them in here. Then what you want to do is you want to put it at an angle like so. Just put it at an angle like that, and there you go. Once you put your fingers in, it should sit flush. Okay. Once we have everything in its place, you want to make sure that the gears are lining up. The bottom gear lining up with the top one, and same goes with that one. This is why you want to wait until the end to screw everything in place. So if everything's in its location, you can put a spool in there, and when you turn it on, voila. This is actually perfect. It's at the 2.5 voltage where we left it. I don't have to open it up or do anything. So now we can just let this spin on its own for whatever reason, and you can just watch it spin. Or, and you can now turn it on and have it spin. And if you want, turn it off, stop spinning, turn it on, it'll keep spinning, turn it off, turn it on, turn it off, turn it on. You get the point. And if you want it slower, counterclockwise will get it slower. You want it faster, clockwise will make it go faster. So I went with ASA filament because of the glass transition temperature is at 105, and the max that this Sunlu dryer goes up to is about 70. So there's a lot of headroom. You can probably use ABS too, which you can, ABS and ASA. You might be able to do PETG, but I'll leave that up to you. I'm not a huge fan of PETG, and I don't think a lot of people are. So you saw how the spool rotated evenly as it dries. You're not going to get any more hot spots or uneven drying spots on the filament. It's just a steady, reliable process that keeps your filament in just great drying condition. I have ran this for nearly 3 to 4 hours continuously on 70 Celsius, and the bar, the whole entire contraption, the print, it's not warped, as you saw. The one other cool thing that might actually happen is, in theory, in my head, it works this way, or I think it does, is I think the spool might also dry up or dry quicker. since it's spinning and it's hitting every single portion of the filament, there's a good chance that instead of running it for 5 hours, you can do it for 4.5 or maybe 3.5 or 4 hours to dry your spools. So you don't have to wait 8 hours, 12 hours. That drying time can be cut in half. Again, there's no real scientific way of figuring out if the filament is fully air dry, but it's there's no real way of seeing moisture leaving the filament, but logically it just kind of makes sense. So I'm thinking that even if the coverage is pretty much evenly throughout the whole filament, it might dry quicker. All of the things that I printed out today, you'll be able to find them down in the link in the description from MakerWorld. I am completely opening this up to the community free of charge. The only thing I ask for you is to share with friends if they have this unit, just so they can, if they want to take on this project, they can do so. We spotted a problem, and instead of waiting for someone else to fix it, we built a solution. That's kind of the mindset or the beauty of making things. I'm not a trinket or tchotchke printer. I don't go out to MakerWorld and print dragons. I see problems. I try to find a solution with my printer. And what I hear a lot, too many people these days say, I can't do that. But if you have that mindset, you're just always going to be stuck and just never move forward. The truth is, if you have an idea, you've already got the first piece of the puzzle to move forward. So here's my challenge to you. Put that phone down, stop doom scrolling, pick up a book, or if you're a visual learner like me, let YouTube become your teacher. Learn if this is where you want to go to print your own ideas, your own designs, and maybe make a buck or two one day out of them. Learning CAD is the way to go. There is a bunch of tutorials out there, and a bunch of free softwares too. So if you're on a Mac, Windows, or Linux, you can pick up free CAD, completely free, open source. Again, tutorials are out there. It is the up and coming software that you can use. I actually did learn from that, and then I moved over to SolidWorks. There was a bit of a limitation for me, but again, for a beginner, just to get their hands on what parametric modeling is, that's where you want to start. And again, it's free. You can't beat that price. Just be consistent, give it 1 week, and I guarantee you, you'll be surprised on what you can do. So that's my goal. Get up your butt, get on the computer, and learn how to use CAD. If this is where you want to go, this is what you want to do, you can do it. And you'll be surprised of what you can create. The tools are all right in front of you. The only thing missing is the choice to start. So thanks for making it this far. If you found this project useful, again, remember to share it with your friends. I'm not one to say subscribe or give me a like. If you want to, go ahead and do that. Thank you so much. Until next time, happy making and happy printing.